example, I want to illustrate a brand new technique, which is actually the equivalent to long division that we used to perform with regular numbers. We can actually perform long division with polynomials. But first, to inspire it, make sure we have the right answer, let's just take a look at this particular division of polynomials. And I want to do it just, first of all, by seeing if I can simplify. So let me write the numerator, which is going to be this, and see if I can factor it right out of the starting block. Notice, by the way, this is a little bit tricky. These people are trying to confuse us. It's not written in the standard way. X squared, it should be plus 6x plus 5. So we have to be a little careful, but I think we can pick up on this. We're not fooled that easily. And I think a 5 and a 1 is going to be perfect. X squared, 1x plus 5x is 6x. 1 times 5 is 5. Doesn't matter how they write it. We can think through it. All over, and then we've got this x plus 5. Notice that now I see these can simplify, and so I see the answer of x plus 1. So x plus 1 is the answer. But this was so easy that we were able to do it just by simplifying. If it wasn't that easy, there's another technique, and I want to illustrate the technique with a simple example so we can see how it works, so that when we apply it to a more challenging example, we're good to go. So the way we do it is just literally long division. So I take x squared, and now I'm going to write the terms in sort of descending order from the powers of x. So x squared, now I'm going to write the plus 6x next, and then plus 5, all divided by, and then I write this. And now I'm going to perform long division like we normally do. It's a little tricky because these are now polynomials. That's okay. We think through it. We look at the very first term here. And look at the first term here. What times x will make x squared? That's the only thing I care about. Well, x times x. So I write an x here. And then I multiply x by this entire quantity. So I see x times x is x squared. X times 5 is plus 5x. And now, what do we do in long division? We subtract. Well, we subtract everything, which means we subtract this and this. So we look up above. X squared minus x squared is 0, which is, by the way it's supposed to always work out. This should actually give us 0. And then I have 6x minus 5x. That gives me just 1x. I bring down the next term, just like we do in long division, and I see x plus 5. Now I look here at the x, and I look here at this, and I ask, what do I have to multiply x by to make it x? The answer is 1. So I add a plus 1. 1 times everything here is 1 times x, 1 times 5. And now I subtract everything. And notice, x minus x is 0, 5 minus 5 is 0, 0, we're done. So what's the answer? The answer is, the quotient is x plus 1. That's the answer. Really? Look back at the easy way we did it, and you'll see we did get x plus 1. So this introduces the idea of long division of polynomials, which can always be applied even when we can't simplify the quotient. Now, we've already seen long division of polynomials, and if you watched any of the videos where we talked about them together, you'll know that I love long division of polynomials. Now, I'm going to show you a very special and I think a little bit controversial way of doing long division of a very particular type of polynomial. So it's controversial because, quite frankly, it uses a slightly modified method than the long division. So the downside is that actually it could be a little confusing because we're going to be doing stuff a little differently than we did before. The other downside is it only works for very, very particular types of polynomials that I'll tell you about in a second. The upside is that it's really short, really direct, and really easy to do. So you have to kind of balance and figure out, do you like it or not? I'll just tell you, since we're friends, I'm not a big fan of this. So even though it's short and easy to do, since I'm worried about getting confused, I tend to always want to do it one way, which is the way that always works, which is long division of polynomials. Let's take a look at an example of what's called synthetic division of polynomials, and then we'll check our answer by doing the old-fashioned long division, and so you can see how these two methods correspond. If you like synthetic division, awesome. And if you don't, that's okay too. Here we go. So I want us to use synthetic division to divide these two polynomials. So here are a couple of rules of the road when you can even use synthetic division. You can only use it in a very special case. When this polynomial over here, first of all, is a linear polynomial, and it must be of the form x minus something. So we can only use this method when we have a polynomial, any polynomial here, divided by, and it's always got to look like x minus a number, I'll call it a. So, if there's a coefficient in front of the x, you've got to do something first to clean that up before you use synthetic division. And if it says x plus 3, that's not good enough. You've got to write it as x minus a number. So in this case, we'd have to write this as x minus, and what's the number to make it x plus 3? It would have to be negative 3. So in this case, we see that the a value is actually negative 3. So already you can see it's a little tricky, right? If there was something in front of this, you have to factor things out and clean it up. But here we see there's only an x alone. That's good. But the plus 3 is no good, so I got to write that as x minus negative 3, and therefore this a term is negative 3. Okay, now that we have it in that form, I just pluck off that term right there, negative 3, and I'm going to write it off here on the left-hand side and put a little half box around it. This is the way we set up synthetic division. Okay, so the first thing to remember is that we have to make sure that the thing that we're dividing here is going to be an x minus a number. In this case, x minus negative 3, and I write the negative 3 here. Then what I do, next to the negative 3, but outside of that half box, I'm going to put all the coefficients of the numerator, all of them, in order from largest to smallest, and make sure I don't leave anyone out. So if there's a term that's not there, notice there's no x term. That means that the x term is there, but it has a coefficient of 0. You have to make sure you write them all in, which is something that we actually do when we do the long division out. So in fact, this is consistent, but we're just going to keep track of the coefficients. So here I see a coefficient of 5. Then that's a cube, so then the square coefficient is a 2. I don't write pluses or anything, I just write them as is. Now, there's no x term. That means there's a coefficient of 0, that's invisible. And then this coefficient here is not 6, but it's negative 6. So if there's a negative number, you have to make sure that you keep that negative sign. Okay, and now here's what we do. We draw just one line with a little space here to put some numbers in. And now here's the process, which will have a kind of deja vu thing to long division, but not quite. So things are going to get a little different. Here we go. First, I just bring down this coefficient right here and write 5. Then what I do is I multiply this number, negative 3, by 5 and write the answer here. And so that's negative 15. And now here's the switch. We add these numbers. So this is a little bit peculiar. If you really think about the long division, we always subtract. In this case, we're actually going to add. So if we add these numbers, then we see 2 plus negative 15 is negative 13. Now I take negative 3 and I multiply it by negative 13 and I get the answer of 39. And now I add 0 plus 39 and I get 39. And now I take negative 3 and multiply it by 39, and if you work that out, you'll see negative 117. And then I add these numbers, negative 6 plus negative 117, and I get negative 123. And then I'm done. Now, you have to admit, this is really easy. First of all, it's just 3 lines, and we're just kind of plucking off the coefficients, and we're done. So now let me tell you how to read out what the quotient is. First of all, take that last number there and put a little box around it, because that represents the remainder. So that's going to be the remainder. And here's the key thing. Remember I told you earlier that you can only use synthetic division when you've got a linear polynomial downstairs in the denominator. So if you've got a linear polynomial, then whatever the polynomial you have up here, you can see its degree, you know that the degree of the quotient will be whatever that degree is minus 1. Because you're dividing, in this case, a cubic by a linear, so the first term is going to be something x squared, which means this is going to be your x squared term. And so what we're going to get here is the following. We're going to see this is the x squared term, this is going to be the coefficient on the x term, and this is going to be the coefficient on the constant term. And so what I can write this as is the answer is, maybe I should use this pen here, the answer is that we're going to get a 5, that's the coefficient, x squared. So you got to remember that since this is a cube, you take that and subtract 1, and so now it's a square. Now this tells you the next coefficient, so minus 13, and then it's the next degree down, so x, and then plus, this is going to be 39 times x to the 0 power, which is just 39, and then we have a remainder of negative 123, which another way of writing that, if you want, let me just show you a different way of writing that, is to say that we see minus 123 over x plus 3. Minus. And so you see there's the polynomial which represents the quotient, but this is also a remainder, and there's the remainder. The remainder is always given in here. If that's a 0, that means you have a 0 remainder. But otherwise, you're going to have that over that, and that's the answer. Now, this way of doing it, let me just remind you, you set things up like this. You can only use this when you're dividing by a linear, which is of the form x minus a. You take the a out here, put it in a box, write down all the coefficients, including the 0 ones that are missing. You bring down the first term, you multiply, and then you add. Multiply, and then add. Then multiply, and then add until you're done. Stop, put a box around there, that's the remainder, and then this starts a polynomial 1 degree less than this, and there you go. So it's not that hard. You see, it's not that hard, but it's a little bit different. Now, you can actually check the answer if you want by actually taking this polynomial and multiplying it through by this and confirming that you get that. So one way to check, in fact, is to actually perform this. So verify that if I take this answer, which is right here, and multiply it by this, and then subtract off 123, because this times this, the numerator and denominator cancel, I'm just left with minus 123. You can verify by just multiplying all this out and distributing that, in fact, this gives you that. But I'm going to actually verify this by actually doing the long division. So let's now actually do the corresponding long division so you can see these different pieces and see that it's a lot longer, but at least it always works. This only works when you're dividing by a linear of the form x minus a. Okay, so big final thing. If you don't want to see it, then just stop right here and have fun. But otherwise, if you want to watch, I'll show you how we used to do this and see how we get the similar corresponding results. So really fast, here we go. So what I do here is I take x plus 3 divided into 5x cubed plus 2x squared plus 0x. I always put in all those terms. We talked about that before. Minus 6. What do I have to multiply x by to make it 5x cubed? Well, 5x squared. Now I multiply everything, so 5x squared times x is 5x cubed, and then 5x squared times 3 is going to be 15x squared. And now what do I do? And this is the part that's a little different than before. We subtract. These cancel by design, and here I see a 2x squared minus 15x squared, which is going to give me a negative 13x squared. So you can kind of see these numbers are kind of appearing here, although the signs are not quite right yet, but you're seeing the corresponding things. You can see how it's unfolding. What do I have to multiply x by to make it equal to negative 13x squared? Well, the answer is negative 13x. So there's the negative 13 that you see there. Negative 13x times x is negative 13x squared. And then if I multiply here, I see a negative 39x. And technically here I brought down the 0x. And now I subtract again the whole thing. Negative 13x squared minus negative 13x squared combined to give 0 by design. Here I see 0x minus negative 39x is going to be 39x. I bring down that last term, so I subtract 6. What do I have to multiply? And there's 39. What do I have to multiply x by to make it 39x? Well, the answer is plus 39. And now, here's the big finish. 39 times x is 39x, and 39 times 3 is positive 117. And now I subtract, and so 39x minus 39x is 0 by design, and now I have negative 6